Okay, so before we begin this lesson, let's list the steps for converting a mixed number to an improper fraction. What do we do first? Don't tell me start with the denominator. What is the actual thing that we do first? Colin.
Multiply the denominator, but multiply the denominator times the whole number.
So we multiply the denominator by the whole number. I'm going to use abbreviations so that we can write this, and then I can just leave it up here. Okay? Then what do I do? Michaela.
Add the numerator. Add the numerator.
Add the numerator. Then what? Zadie?
Your total becomes the
Answer equals the new numerator. Where does the denominator come from? Zari?
The denominator stays the same.
Denominator stays the same. So if I have the mixed number 2 3/4, 4 is the what, class? Denominator. 2 is the whole number. And 3 is the numerator. Okay, so there's mixed numbers to improper fractions. Now on the other side of the board, let's put improper fractions to mixed numbers. What do we do first? Zadie.
You divide the numerator by the denominator.
So, numerator divided by the denominator. Then what? Smith.
The quotient, only the whole number becomes the whole number.
Bless you. So, this one I am going to write out because it's a little different. The whole number, no remainder, and I'll move, no, you can't see this, equals the new numerator. Then what? Wait, not the new numerator, the new whole number, which I will put a W because it means the same thing as the mixed number. Then what? So the whole number with no remainder becomes the new whole number. Carla.
The amount left over remainder is numerator.
Remainder equals the numerator. Then what? What's the last bit that we need, Lena?
The denominator
The denominator stays
stays the same.
the same. And if we have 11/4, 11 is the class numerator. Oops, that looks like a W. And the 4 is the denominator. And there, sorry, can you see all that now? Okay. Okay. So, for this lesson, instead of decomposing and using associative property, there is no such thing as the associative property of subtraction. We can't do it with subtraction. Remember, subtraction doesn't have properties, it has rules. So we can't group things together and subtract, because if we broke down 4 3/4 into a sum of its whole numbers and fractions, it would look like this. And that's addition, not subtraction. So when we would group it, we'd have to be adding. Well, we're not adding, we're subtracting. So what we have to do with subtraction is that we have to convert our pieces into improper fractions. But then when we're done, we have to change the answer back into a mixed number, unless we get lucky and the answer is a regular fraction, which we may or may not see today. No, we won't. Except for potentially on the homework. So check to make sure. If you get your final answer and the numerator is smaller than the denominator, that means you're done, unless you have to put it in simplest form. You don't have to convert. Because if you end up with an answer like this, and you try to turn it into a mixed number, well, the numerator divided by the denominator, is that going to work? How many times does 4 go into 3? Class? 0 times. Can we have an answer that is just 0? No. So, pay attention. If you get your answer when you subtract the improper fractions and the numerator is smaller than the denominator, you're done, unless you have to put it in simplest form. Do not turn a regular fraction into a mixed number, because it won't work. It will not work. You will end up with the exact same answer. 4 goes into 3, 0 times. 0 times 4 is 0. 3 minus 0 is 3. If we follow the instructions, our answer without the remainder becomes the whole number. Our remainder becomes the numerator. Our denominator stays the same. 0 3/4 is exactly the same as 3/4. So, if you end up with an answer where your numerator is smaller than your denominator, do not try to convert it to a mixed number, because you're going to end up with the exact same thing. Okay, so everybody, finger or pencil on example 1. Remember, with subtraction, the most important thing is when you have a word problem and you're writing your equation, which number has to come first? No matter what the numbers are, which one has to come first in a subtraction problem? Carla?
The greater number.
The greater number, the bigger number. So be careful. Don't just necessarily put numbers in the order they come. Check to make sure that you're putting the biggest one first. So everybody, let's look at example 1 and read in your head while I read out loud. Olivia had 4 3/4 boxes of games. Okay? That means she had 4 whole boxes of games and then 3/4 of another one. Maybe she was missing some pieces. She gave 1 1/4 of the boxes to her brother. She gave 1 whole game and a part of another game to her brother. How many boxes of games does she have left? So we know, does she have left is usually a sign that we're going to be subtracting. Because we're starting with a certain amount, we're taking some away, and then we're figuring out how much is left. So we need to go into this problem and we need to figure out which fraction is greater. Is it 4 3/4 or is it 1 1/4? Which of those mixed numbers is greater? Smith?
4 3/4.
4 3/4, and I'm going to tell you something right now. When you're trying to figure out which one is greater, look at the whole number first. Because if I have 4 whole games, that's bigger than 1 whole game, right? So that's a hint right away. Whichever number has the larger whole number is going to be greater. If they both have the same whole number, that's when you need to look at the numerator for the fraction part. But look at the whole number first, not the fraction. We'll see an example of that on example 2. So 4 3/4 is bigger. So it's going to be the minuend. Class, what is the first number in a subtraction problem called? The minuend. And then our second mixed number, 1 1/4, will be our subtrahend. Class, what is the second number in a subtraction problem called?
Subtrahend.
Who remembers the answer? What is the word? What is the vocab word for the answer to a subtraction problem? Mason? The difference. Minuend, subtrahend, difference. Minuend, subtrahend, difference. Okay, so step 1 is to take each of these numbers and turn it into a mixed number. I mean an improper fraction, sorry. Now they have this whole long way, but we have a much easier way. So, for 4 3/4, we're just going to solve it to the side and put the answer here. We know we start with the denominator and multiply it by the whole number. The denominator is 4. The whole number is 4. Class, 4 times 4 equals
16.
16. Then we know we add the numerator. The numerator is 3. Think about it. Class, 16 plus 3 is
19.
19. We know the answer is our new numerator, so 19 is our numerator, and we know the denominator stays the same. So class, 4 3/4 is equivalent to 19/4. Now we're going to do the same thing with our subtrahend. We're going to start with the denominator and multiply it by the whole number. Our denominator is 4. Our whole number is 1. Class, 4 times 1 is 4. Then we're going to add the numerator. The numerator is 1. Class, 4 plus 1 is 5. We know the answer is our new numerator. And the denominator stays the same. So 1 1/4 is equivalent to 5/4. Now we're just going to subtract like fractions. We take each mixed number, improper fraction. We write them in the same order. So whatever 4 3/4 is equivalent to goes first. So we do 19/4 minus 1 1/4 is equivalent to 5/4. And we just subtract like fractions. That means subtract the numerators like normal. Think about it, class. 19 minus 5. Think about it. Make sure you have the correct answer. Don't call out an incorrect answer because you're not thinking. Class, 19 minus 5 is
14.
14. We know the denominator stays the same. So 19/4 minus 5/4 is 14/4. Can we leave an improper fraction as our final answer? Nope. So now we need to do the other part. So first, we divide the numerator, 14, by our denominator, 4. Think about it, class. 4 goes into 14. Think about it. Class, 4 goes into 14. How many times? 3. Class, 3 times 4?
12.
Class, 14 minus 12? 2. Now we know the whole number without the remainder is our new whole number. So, our new whole number is, class? 3. Come on. The whole number, which is the answer without the remainder, is our new whole number. Class, what is our new whole number for our mixed number? 3. The remainder is the new numerator. What's our new numerator, class?
2.
2. Our denominator stays the same. What's our denominator? 4. So 14/4 is equivalent to,
3, 2,
come on class, 14/4 is equivalent to,
3,
3 2/4.
but what's wrong with that? Zari,
It's not in simplest form.
it's not in simplest form, so we need to find the greatest common factor. Zari, factors of 2,
1 and 2.
factors of 4,
1, 2, and 4.
common factors,
1 and 2.
1 and
2.
2, greatest common factor.
2.
So, we divide the numerator and the denominator, each by 2. What do I need to make sure to do before I start dividing, Zari? Who can help her out? What do I need to make sure to do? Michaela?
Put your whole number.
Move my whole number. So I'm not saying that 3 2/4 is equivalent to just a fraction. So I need to move my whole number. Now I can divide. Class, 2 divided by 2,
1,
4 divided by 2.
2.
So 3 2/4 is equivalent to
3 and 1/2.
3 1/2. So read this sentence, fill in the blank. Ethan, read the last sentence, fill in the blank. So Olivia has, read the whole thing.
So Olivia has 3 and 1/2 boxes of games.
Good. So Olivia has 3 1/2 boxes of games left. So yes, takes a little extra. But the more you practice, this takes a lot less time than associative property. You just have to practice. But it actually takes a lot less time because you're not writing so many ones and so many fractions, and you're not having to rewrite the same problem again, just putting it in groups. You just have to practice. And notice how all we're using for this multiplication and this division is basic facts and patterns. I mean, not basic facts and patterns, just basic facts. That's all you're using. So if you know your basic facts, you're good. All you have to do is make sure that you're not making a silly mistake. Make sure you know your basic facts. Okay. Is everybody with me? Yes, you do have to convert. We will see why you can't just look at it and say, well, 4 minus 1 is 3. And 3 minus 1 is 2. Because you're not always going to have a smaller fraction in the subtrahend. Sometimes the larger whole number has the smaller fraction. So you have to regroup. But turning it into an improper fraction first, you don't have to worry about regrouping. Okay, so everybody turn to example 2. Okay, everybody, finger or pencil on example 2. Make sure that you're working with me, not working ahead. Because you might miss out on something. Okay, the problem says find 3 1/5 minus 2 2/5. Now this is why we can't just say, okay, 3 minus 2 is 1, because then we get to 1/5 minus 2/5. Can we do that? Can our minuend be smaller than our subtrahend in 4th grade math? No, it cannot. So that's why we have to convert. So, step 1, we're going to take our minuend and our subtrahend and we're going to turn them into improper fractions. So our minuend, 3 1/5. We know step 1, we start with the denominator multiply it by the whole number. Class, what is the denominator in 3 1/5? Class, what is the denominator in 3 1/5? I need everybody answering. I don't hear everybody's words. Class, what is the denominator in 3 1/5?
5.
We multiply it by the whole number. What is the whole number in 3 1/5, class?
3.
Class, 5 times 3 equals?
15.
Then we add the numerator. Class, what is the numerator in 3 1/5?
1.
Class, 15 plus 1 is?
16.
The answer is our new numerator. So our new numerator is 16. The denominator stays the same. What is the denominator, class?
5.
5.
So 3 1/5 is equivalent to?
16.
Class, 3 1/5 is equivalent to?
16.
16 fifths.
Good. Now we have to do the same thing with 2 2/6. We start with the denominator and multiply it by the whole number. Class, what is the denominator in 2 2/5?
5.
We multiply it by the whole number. What is the whole number, class?
2.
2.
Class, 5 times 2 is?
10.
10.
Then we add the numerator. Class, what is the numerator in 2 2/5?
2.
2.
Class, 10 plus 2 is?
12.
12.
So our new numerator is?
12.
And our denominator is?
5.
2 2/5 is equivalent to?
12 fifths.
12 fifths.
Now we just subtract like fractions. We know 3 1/5 is equivalent to 16 fifths. 2 2/5 is equivalent to 12 fifths. Now we just subtract the numerators. Class, think about it. What is 16 minus 12? Think about it. Don't just call out an answer. Class, 16 minus 12 is?
4.
4. Class, 16 minus 12 is?
4.
4. Denominator stays the same. What is the denominator?
5.
So, 16 fifths minus 12 fifths is?
4 fifths.
4 fifths. Zari, make sure I can see you. Wait a second. What do you notice about the answer to our subtraction problem? Lena?
It's already in simplest form.
It is already in simplest form, but what else do you notice? Because 5 is prime, 4 is not, but 4 is not a factor of 5. What else do you notice about 4 fifths that's different from example 1? Victoria? What did we have to do after we did the subtraction in example 1? What did we have to do next? Zari?
The numerator was an improper fraction.
Well, not the numerator, just the whole fraction was improper. So we had to convert the answer to our subtraction problem into a mixed number. Do we have to do that here? And why? Ooh, I saw a bunch of hands go up, and then as soon as I said why, they went down. If you don't know why, it's not going to help you get that answer again. We don't have to convert to a mixed number. Why, Cullen?
Because 4 is smaller than 5.
Because our numerator is smaller than our denominator. What is an improper fraction? What is the definition of an improper fraction? Carla?
Improper fraction means when the numerator is greater than the denominator.
So an improper fraction, the definition is a fraction where the numerator is greater than the denominator. Is that the case for 4 fifths? Is our numerator greater than our denominator in 4 fifths? So do we have to convert it? No, pay close attention, because what I can tell you right now, some of you are going to do is, even though this is not how you do it, you're going to put 5 here and do this. 4 goes into 5 once. 1 times 4 is 4. 5 minus 4 is 1. So that means 4/5 equals 1 and 1/4. But that's not correct. But you're going to think, oh, I have to convert because I've done it every time before. So let me put the bigger number inside the bracket and the smaller number outside. Even though right here I'm dividing the denominator by the numerator. And is that what I do? Do I divide the denominator by the numerator? So pay attention. If you get the answer to your subtraction problem and the numerator is smaller than the denominator, stop. Check for simplest form, then you're done. Don't convert a fraction where the numerator is smaller than the denominator into a mixed number. Do not do it. Leave it alone. Check for simplest form and then be done. But as Lena told us, 4/5 is already in simplest form. So class, 3 1/5 minus 2 2/5. Please think about your answer for a second. Is
4/5.
4/5.
We can use addition to check, but we're not going to worry about that. So, does everybody see how most of the time today you will have to convert this answer to a mixed number? But will you have to do it every time? Check. More likely than not, that means most of the time you will have to then convert this answer to a mixed number and then check for simplest form, but not always. When you convert a mixed number to simplest form, what do you need to make sure that you do? When you when you change a mixed number to simplest form, what do you need to make sure that you do? Wake up, think. I said it so many times on Friday, and then we said it again today. Smith?
You need to make sure you list every single factor.
Okay, but that's not what I'm talking about. When you convert a mixed number into, or change a mixed number to simplest form, what do you need to make sure to do?
You need to make sure you move your whole number.
You need to make sure that you move your whole number. Otherwise, you're telling me that 3 2/4 is equivalent to 1/2. If I said you can have 3 2/4 of a cookie or 1/2 of a cookie, which one are you going to choose? Are they the same? Which one are you going to choose? If you like cookies. Lena? 3 2/4. So don't tell me that, otherwise I'm just going to give you half of it instead of 3 1/2. So do not forget that. Okay, let's look at the guided practice. This is where you will need to start using your separate sheet of paper. So you can go ahead and label your separate sheet of paper however you would like to get started with the guided practice, because you will need more space. Yes, Zari. Okay. Number 1. Find each difference, write in simplest form. Aaron, we have 5 4/8 minus 1 1/8. What do we need to do first?
Write each mixed number as an equivalent to
So first we need to convert our mixed numbers into improper fractions. So let's start with our minuend, 5 4/8. What do we need to do? Tell me in words, then we'll do it in numbers.
We need to
Blah, blah, blah.
multiply 8 times 5.
Tell me in words, then in numbers. Otherwise, you're telling me every time, like even in number 2, the first thing we do is we multiply 8 times 5. We multiply the, Aaron, there's several places you can look. You have an anchor chart. You have steps on the board. Don't just stare at the problem and expect it to just pop out at you. Look at your tools. You have steps up here on the board, you have an anchor chart, both of which tell you exactly what to do in words. So what do we do first? We multiply the We multiply the denominator by the whole number, not times the whole number. Multiply tells us to do that. We multiply the denominator by the whole number. So that means in numbers, what are we multiplying? 8 times 5, which equals 40. Then what do? Tell me in words. We add the numerator, which means we are adding 4. 40 plus 4 is 44. Okay, now what?
That total becomes the denominator stays the same.
Wait, you just said that total becomes the denominator stays the same.
I meant to say the
Okay, well, so the denominator stays the same. But what about our numerator? You never told me what our numerator was. Where do we get our numerator?
44.
Always, no matter what, even if we have a problem like this?
The numerator is
Look at your paper. Is the answer, does this book tell us in words? Where can you look to see the words that tell us what our new numerator is? It's not in the book. The book taught us a different way. Aaron, look at your anchor chart. What step tells us where our numerator comes from? Where do you see the keyword numerator?
that total becomes the numerator.
Okay, the total of what? Who can help her out? What total? Zadie.
The total from when you added.
So when we multiplied, Aaron, this is, you gotta go in order. You told me the denominator before you told me the numerator. So you told me multiply the denominator by the whole number, which we got 40. Then we add the numerator, we got 44. That total becomes the new numerator. The words you said were the new numerator becomes, the denominator stays the same. But you didn't tell me what the new numerator becomes. So that total, after we did this multiplying and adding, is our new numerator. So what is our new numerator? 44. And then, what do we know about the denominator? What do we know about the denominator? What happens to it? It stays the same. Now we need to do the same thing to 1 and 1/8. So, what do we do first? Tell me in words. Aaron, we're doing the same exact thing, just with 1 and 1/8 instead of 5 and 4/8. So where can you look to find the steps? It's not in our math book. We're following the same exact steps, just with a new number. There are two other places to look. Which one tells us? This one or this one? What are we doing? Are we converting a mixed number to an improper fraction, or like the top part of your anchor chart? Or are we converting an improper fraction to a mixed number, or the bottom part of your anchor chart? Is this an improper fraction? What is this? 1 1/8. A mixed number or an improper fraction? So which one are we doing? So what do we do first when we're converting a mixed number to an improper fraction? We just did it with a different number. Step 1. And what do we do with it? Aaron, step 1.
We divide the denominator times the whole.
Okay. Aaron, it's right here. If this one is confusing, look at this one. What is the denominator? 8. What is the whole number? 8 times 1 is 8. Now what do we do?
We add the number.
What is the numerator?
1.
8 plus 1 is? Now what?
The numerator is the answer to. The numerator is the answer to our addition.
Okay. What is our new numerator?
The denominator stays the same.
And now we just subtract like fractions. You may have to subtract to the side. Again, that's why you have your separate sheet of paper. 44 minus 9, we're going to have to regroup. So, on our separate sheet of paper, we're going to write 44 minus 9. Aaron, can you do 4 minus 9?
No.
No. So we have to move to the tens place and do what? We have to regroup, which means we take 1 10 away. So how many 10s do we have left?
3.
And we give that 10 to the ones place. So how many ones do we have? 14. Now 14 minus 9. Can we do that? Yes. 14 minus 9 is 5. Now we can move to the tens place. 3 minus nothing is, which means 44 eighths minus 9 eighths. I'm sorry, 44 minus 9 is 35. How do we know the denominator? It stays the same. Now we have 35 eighths. Can we leave our answer like that? No. So on our separate sheet of paper, now we are converting a what into a what? An improper fraction into a mixed number. So step 1, divide the numerator by the denominator. The numerator is 35. The denominator is 8. 8 goes into 35. How many times?
3 times.
Is that close enough? No. 4 times. 4 times 8? 32. 35 minus 32? We don't have anything to bring down, so we're done. Now, what does that mean? How can we get our mixed number from here? What's our whole number?
The whole number is 4.
And what's our numerator? The numerator stays the same? This is why we need to say it in words. The answer, the whole number without the remainder, becomes the what in our mixed number? The new whole. Now, where do we get the numerator? So our numerator is, this is why it's so important to know the words, because then you're not just guessing at which one. If you know that the remainder is the new numerator, then you know to look at the remainder, not here or here. And the denominator, it stays the same. Now we need to check for what? Simplest form. Is it in simplest form, or do we need to put it in simplest form? It's in simplest form. 3 is prime. It is not a factor of 8. So, Aaron, 5 and 4/8 minus 1 and 1/8 is 4 and 3/8. Now we're going to do the same thing with number 2. Remember, the process stays the same, just the numbers change. So, when you can get the words like that, it's easy. But you need to memorize the words first, because the words tell you where to look. If you just do the numbers every time, you're not necessarily going to remember where the words are tomorrow when we haven't been talking about it for a whole night. So we're going to do the same thing with number 2. Now in numbers 1 and 2, on your independent practice, you can fit the improper fraction subtraction underneath it, but on the homework you're not. So you're going to have to do this part on your homework on your separate sheet of paper too, because you're not going to be able to fit it. If you look at the homework, I'm giving you printed ones, but it's the same thing basically. So do you see you're not going to have space to do this subtraction underneath. You're going to have to do that on your separate sheet of paper as well. And the only thing you'll have on your paper is the original answer, the division if you need to put it in simplest form, and then the answer in simplest form. Okay, so we're going to do the same thing with number 2. 6 and 1/3 minus 2 and 2/3. Mason, what do we have to do first when we're subtracting mixed numbers? This is where, so when you're subtracting, we have mixed numbers. Do we just subtract these mixed numbers like 6 minus 2 is 4 and 1 minus 2? Uh-oh, can't do that. What do we do with these numbers first?
You multiply the denominator.
Because what are we trying to do with these numbers? Smith? Turn them into improper fractions. Look at step 1 in the book. Look at step 1 in the book. What does it tell us to do? So, first, we have to write each number as an improper fraction. Now we can go to the anchor chart, because now we need to turn our minuend, 6 and 1/3, into an improper fraction. So what do we do first? Tell me in words first, please. Multiply the denominator by the whole number. What's the denominator?
3.
What's the whole number?
6.
3 times 6 is? 18. Now what do we do? Make sure to tell me in words. Add the numerator. What is the numerator?
1.
18 plus 1 is? 19. Now what?
The total becomes the new numerator.
So what's our new numerator? 19. And the denominator?
3.
In words?
Oh,
What happens to the denominator?
it stays the same.
So our denominator is?
3.
Okay? Now, do we we do anything different to the subtrahend? Do we do it a different way? No, we do it the exact same way. So in words, what do I do first? Multiply the denominator by the whole number. What's the denominator?
3.
What's the whole number?
2.
3 times 2 is?
6.
Now what do we do?
Add the numerator.
The numerator is?
2.
6 plus 2 is?
8.
So now what?
The total becomes the new numerator.
So our new numerator is?
8.
And the denominator?
Stays the same.
Now we can just subtract. We subtract the numerators. Now, do we have to regroup here like we did 44 minus 9, or can we just go ahead and subtract place by place?
You can just go ahead and subtract.
19 minus 8 is?
Um,
Let's look at the places. The ones place, 9 minus 8 is?
1.
1. 10's place, 1 minus nothing is?
1.
So 19 minus 8 is?
11.
And our denominator?
3.
Because it
Stays the same.
stays the same. So we have 19 thirds minus 8 thirds equals
11 thirds.
11 thirds. Can we leave our answer like that?
No.
No. So now we need to convert this what into a what?
You need to convert the improper fraction to a mixed number.
We need to convert the improper fraction to a mixed number. How do we do that? Tell me in words. What's the first thing we do?
Divide the numerator by the denominator.
So we're dividing 11, our numerator, by 3. Now think about it for a second before you answer. But 3 goes into 11
3 times.
3 times. 3 times 3 is
9.
11 minus 9 is? We don't have anything to bring down. Now, how do we pull out our answer from here? Tell me in words. The whole number of our mixed number comes from the, you can look over here if you can see it. If not, look for the keyword whole number on your anchor chart. Where does the whole number for our mixed number come from? What are the 3 parts? We have the what? What is this part called? Who can help them out? That's why we got it. This is why you've got to know the words. Where does the whole number for our mixed number come from? Only 3 people? Can tell me in words? Well, 2. You got to tell me in words. Zari, where does the whole number for our mixed number come from?
The whole number comes from the answer from our division problem.
The whole answer?
No, just the answer
Guys, look at step 2.
that we got from
Look at step 2.
multiplying to get our
Look
answer.
at step 2 in improper fractions to mixed numbers in both places. Look at step 2 on the board and on your anchor chart. Where does the whole number for our mixed number come from? Mason? The quotient, but the whole quotient? The whole number and the remainder? Can we write 3 remainder 2 as our whole number? So the quotient, but look at example 2. I'm sorry, look at step 2. Cullen?
The quotient, only the whole number becomes the whole,
So not the remainder. The quotient or the whole number without the remainder becomes the whole number in our mixed number. So Mason, what is the whole number in our mixed number? Knowing that it's the quotient or the whole number part of our division answer, not the remainder. 3. And then where does the numerator come from? The remainder. So what's our numerator? 2. And then where does the denominator come from? It stays the same. Now we need to check for simplest form. Is it in simplest form or do we need to put it in simplest form? It's in simplest form. Our numerator and our denominator are both prime. So that means 6 1/3 minus 2 2/3 is 3 2/3. Okay, what we're going to do is we're going to look over the independent practice. Okay, you guys have got to learn the words. Do you see how once we got to the guided practice where you do most of the talking, we moved away from the examples where I do most of the talking to where you do most of the talking? Because you guys don't know the words, it was taking a really long time. Because you have to tell me the words, because when you don't know the words, you're like, well, which part do I look at? Well, here my answer was 3, but like, what's my answer now? Carla, sit up. Carla, sit up. The words tell you exactly where to look. It's not changing. The process does not change. Only the numbers do. So if you know the words, the numbers will come easy to you, but you have to know the words. You have 2 places to find the words. Your anchor chart, which you all have, and the board up here. The words are in both places. Make sure, Zari, please turn your camera on, that you know the words. Once you know the words, the numbers come easily. Okay, let's look at the independent practice. Numbers 4 through 11, you're doing the same exact thing we've been doing all morning. You do have space to write the improper fraction subtraction. However, you're going to show how you converted and make sure to show if you need to simplify on your separate sheet of paper. Carla, if you need to stand, then please stand. I think it will help to stand. Please stand up, and that will help to wake you up. You need to show how you converted on your separate sheet of paper, and you need to show simplifying on your separate sheet of paper. The answer, and then the division, if you need to put it in simplest form, can be on the math book paper. For independent practice, this can also be on your separate sheet of paper. Numbers 12 through 14 are word problems. Remember, on the line you need the equation, the answer in simplest form, and the unit. You'll have to show all work on your separate sheet of paper because you won't have space. Do not forget equation, answer in simplest form, unit. Numbers 15 and 16 are critical thinking, one with numbers, one with words. Then look at the homework. I will give you a printed sheet, but it is set up in the same way. Numbers 1 through 8 are exactly like what we've been doing all morning. You will need to show all work, including the improper fraction subtraction, on your separate sheet because there's just no room to put it on that paper. Numbers 9 through 11 are word problems again. Equation, answer in simplest form, unit, go on the line, all work gets shown on your separate sheet of paper. Number 12 is a word problem. you can show the equation, the answer in simplest form in the unit, right there to the side, but you need to show the work on a separate sheet of paper. If you know the words, then finding the answers will be quick. If you don't know the words, then you're going to question yourself on every problem. Okay. For the next 20 minutes, you must work on independent practice. After 20 minutes, you will have a choice. And I will tell you what that choice is in 20 minutes. So go ahead and get started.